Good morning, dear students. Welcome back. This session is in continuation to the previous session for today, that is block diagram, the generic block diagram, IoT things, devices, and IoT protocols. Now, to start with, what protocols are? Protocols, if we go into thick of things, we all have a question that how these IoT devices are communicating with each other over an IoT network, or how simply an IoT network works, how the various devices that are connected are communicating with each other. So if we remember, whenever a particular device communicates with other devices, we require a set of protocols or a set of rules through which this communication is made possible. So these devices can communicate with the other devices through protocols or rules which are known as IoT protocols. The protocols are defined as a set of rules, regulation, and guidelines of how to react for commands from another device.
IoT protocols are used to establish communication between a node and a server over the internet. Now, these protocols are very important while the several IoT devices are in communication with each other. The general purpose protocols already used, that is CDMA, WAP, etc., are not suitable for this specific IoT technologies. So, we require dedicated protocols for IoT technology as it needs some more powerful protocols. IoT protocol help to establish communication between IoT devices, that is the node devices or the things that we have already elaborated upon, and the cloud based server over the internet. It helps to send commands to the IoT devices and also receive the data from the IoT device that is connected at the receiver end. We can see in the diagram that is given here in the slide that what is the underlying protocol set that is used. The various protocols are basically divided into 4 layers, and according to the layer the protocols are mentioned and will be elaborated one by one. As we all can see in the protocol suite that is given over here, it constitutes of 4 layers. The lowermost layer is the link layer, the next layer is the network layer, then we have the transport layer, and then we have the application layer. Each layer constitutes of different protocols that are performing the functionalities specific to that particular layer. In the link layer, we have 802.3 Ethernet, 802.16 WiMAX, 802.11 Wi-Fi, 802.15.4 LRWPAN, 2G and 3G cellular networks. In the network layer, we have IPv4 protocol and IPv6 protocol and 6 LoWPAN. Then we have TCP and UDP protocols in the transport layer. In the application layer, we have a set of protocols that provide functionality at the application level. The first and the foremost is HTTP, then we have CoAP, we have WebSockets, we have MQTT, we have XMPP, we have DDS, and we have AMQP. Now we will be elaborating on each and every layer in detail, starting with the link layer, the functionalities and the respective protocols that are working in this particular layer, to the network layer, then to the transport layer, and then to the application layer. We will be starting with the lowermost layer in the IoT protocol suite. It is the link layer. Now all the responsibilities of the link layer are similar to the data link layer that is provided in our OSI model or the TCP IP model. Over here, the link layer protocols are basically used to send the data over the network. and it is basically related to the physical encoding of the particular data sets. It determines how the packets are coded and signaled by the devices. It basically determines how the data is physically sent over the network's physical layer. At the physical layer, we have the connectivity cables, copper wire, coaxial cables and radio waves. So it basically determines how the data is physically transmitted over these mediums and how it is encoded. We have various standards as mentioned and shown in the protocol suite in the previous slide. We have IEEE 802.3 standard. This is Ethernet protocol for coaxial cables. Then we have IEEE 802.3i. This is Ethernet twisted pair. This provides a transmission data rate of 10 Mbps to 40 Gbps. Then we have IEEE 802.3j, which is Ethernet fiber. We have IEEE 802.11, which is wireless LAN. It provides a data rate of 1 Mbps to 6.7 Gbps transfer. Then we have IEEE 802.16. This is Wi-Fi Max. It provides a data transmission rate of 1.5 Mbps to 1 Gbps. Then we have IEEE 802.15.4 standard. This is for wireless personal area networks. It provides a data transfer rate of around 40 kbps to 250 kbps. Now, based upon the requirement of the data rate, we can choose for the respective standards that are provided in the link layer. This layer in short determines how the packets are coded and signaled by the hardware device over the transmission medium to which the sender and the receiver is attached. Now, as discussed already, the 802.3 Ethernet standard. Ethernet is basically a set of technologies and protocols that are used primarily in LANs. It was first standardized in 1980s by IEEE 802.3. We also have 802.11 Wi-Fi. This is a part of the IEEE 802 set of LAN protocols, and it specifies the set of media access control, that is MAC, and physical layer protocols for implementing the wireless local area network, which is WLAN. Then this WiMAX 802.16 is a standard for WiMAX technology. It provides us communication over a wireless metropolitan area network, WMAN. It has been developed by a working group number 16 of IEEE 802 and specializes in point to multipoint broadband wireless group. Similarly, 802.15.4 standard, which is LRWPAN. This is a collection of standards for low rate wireless personal area network. This IEEE 802.15.4 standard defines the MAC and physical layer used by, and is not limited to the networking specifications used for ZigBee, 6LoWPAN, ThreadWison and MyWI protocols. Now, this 2G, 3G and 4G mobile communication standards are basically different types of telecommunication generations that are being used by the different IoT devices. IoT devices are basically based on these standards and can communicate over the cellular network. The next layer in the protocol suite is the network layer. The network layer is basically used to send the datagrams from the source network to the destination network. Now, what these datagrams are? The datagrams, also known as the packets, are basically used to divide the data that is being sent over the communication channel from the source node to the destination node. So the data is basically divided into packets, which is known as datagrams, and these are routed from the source network to the destination network. So the network layer is responsible for sending these datagrams or packets from the source to the destination network. The each and every packet or datagram constitutes of the host address, that is the source address, as well as the destination address. So it is also responsible for host addressing as well as for packet routing, that is from the source network, from the source node to the destination node, what route will be taken to transmit these datagram packets from the source to the destination. The addressing schemes that the network layer uses are IPv4 and IPv6 protocols. These are used for host identification. As we all know that IP addresses are internet protocol addresses. These are numerical labels which are assigned to each and every device over the network, so as to uniquely determine or identify the devices over the network. Obviously, for when they are communicating, we should be able to identify each and every device connected over the network uniquely. So it is for unique identification. These through two internet protocol versions, IPv4 and IPv6, are used at the network layer. Now to elaborate on the IPv4 and the IPv6 protocols, the IPv4 is Internet Protocol Address, and it defines a 32-bit number. It's version 4 basically. So the Internet Protocol Address is nothing but a numerical label assigned to every device connected over the network. So IPv4 is basically version 4, which uses a 32-bit number or a 32-bit address scheme to calculate the addresses of the devices. However, these addresses have already got exhausted in 2011 due to the increase in the number of devices. So we all can imagine that how many number of devices are there over the network. So the next version that is in use is IPv6, which is Internet Protocol version 6. It is the most recent version of the IP protocol, and in this communication protocol, it provides identification and location system for the various devices attached to the network. It uses a 128-bit addressing scheme, and it was developed by Internet Engineering. It is used to route the traffic across the internet using this 128-bit address scheme. Then we also have a 6 low PAN. This is basically a low power wireless personal area network and is an acronym of IPv6 over low power wireless personal area network, and it is a working group in the internet area of IETF. It is basically responsible for bringing the IP protocol to low power devices. So this is the network layer, which is basically responsible for source to destination addressing and routing of the datagrams and the packets with the help of IPv4 and IPv6 protocols. The next layer in the protocol suite is the transport layer. The transport layer basically is responsible for providing end-to-end message transfer capability. This is independent of the underlying network. This particular layer provides functions such as error control, segmentation, flow control, and congestion control. Now, error control is basically responsible for transmission of the packets or the datagrams error free. That is when they are routed from the source to the destination. Then in between the transit, the packets may get some kind of error. So there are error control mechanisms which are implemented over this particular layer, and it ensures that error free delivery of the packets is made at this particular layer. Similarly, segmentation is there. Segmentation is basically whenever we are dividing our data into packets or into datagrams, then we need to assign unique numbers to the datagram packets, so that when they are received at the destination node, then they can be arranged in order. So segmentation is basically providing segment numbers to these packets, so that at the destination these segments of the packets can be arranged in the order they were transmitted. Then we have flow control. Flow control basically manages the rate of flow between the sender and the receiver device. Then we have congestion control. Congestion control is basically responsible for identifying that whether a particular route is congested, that is from the source to the destination. If there are multiple routes, then a route that is having less congestion or is congestion free is chosen over a route that is having a greater congestion. So this transport layer is also responsible for providing congestion control at the time of communication between the source and the destination node. Now this transport layer basically makes use of two protocols, which is TCP and UDP. TCP is transmission control protocol and UDP is the user datagram protocol. Now transmission control protocol is a protocol which defines how the communication is or how the connection is going to be established between the source node and the destination node, how this particular network is going to be maintained, and how the exchange of data is going to happen in a proper manner using the internet protocols. The user datagram protocol, however, at the contrast or at the contrary, is an internet protocol which is connectionless, in the sense that this protocol does not require to establish the connection to transfer the data. TCP is a connection oriented protocol and UDP is a connectionless protocol. By connection oriented, we mean that the whole responsibility of establishing the connection, transmission of the packets over the connection, and then the end of the connection, all will be taken care by the protocol itself. However, UDP is not at all concerned with the establishment of the connection or the reliable delivery. So TCP is a much more reliable protocol and UDP is basically a connectionless protocol. TCP is basically widely used by web browsers, by email programs, or in file transfer applications. However, UDP is basically used where time sensitive applications are there, where a small amount of data will be exchanged. Because of the connectionless or stateless property of UDP, it is not chosen for very large communications. TCP provides error detection, it also provides flow control capability, it ensures the transmission rate, and it also provides congestion control capability. However, UDP does not provide any kind of guaranteed delivery of the user packets. Okay, so to summarize, TCP is transmission control protocol. It is connection oriented. It is a standard that defines how to establish and maintain a network conversation over the application programs. The TCP works with the internet protocol. It defines how the connection is established, how the whole connection is maintained, and how the packets will be transmitted. It ensures end-to-end delivery. However, UDP is a connectionless, stateless transport layer protocol, which is unreliable. It does not, there is no need to establish connection prior to the data transfer, and it is not, it does not provide any kind of services such as your congestion control or flow control or error control. It is basically used where a small amount of data needs to be transmitted. So the last layer in the protocol suite is the application layer. This layer defines how the data can be sent over the network, with the lower layer protocols using the application interface. This application layer is basically responsible for defining how the application interfaces with the underlying layers, how the data is being sent over the network from the source node to the destination node. The application data, which is in files, is encoded and encapsulated in the transport layer, which is providing the connection or the transaction oriented communication over the network. So the application layer protocols enable process to process connections using port numbers, or we can say specific port addressing is used in application layer. The transport layer is basically responsible for end-to-end message transfer. However, here the application layer is basically responsible for process-to-process communication. That is, the specific port-to-port addressing is used in the application layers. Now, if we see over here, there are a number of application layer protocols that are used and are listed, which we will be taking in detail. We have HTTP, Hypertext Transfer Protocol, we have WebSocket, we have MQTT protocol, we have CoAP, we have XMPP, we have DDS, we have AMQP protocols. These all protocols work in the application layer. Now we will be elaborating on each and every protocol in detail. To start with, the first one is the Hypertext Transfer Protocol. Now, this protocol is an application layer protocol for transmitting hypermedia documents. We all know what hypermedia documents are. We all deal with the hypertext documents in our day-to-day life. Basically HTML documents. So it constitutes of text, video, audio, every kind of hypermedia documents are included. It was this particular protocol was basically designed for communication between web browsers and the web servers. It can also be used for other purposes apart from being used by the web browsers and the web servers. It basically makes a request to the server and then waits until it receives a response for the particular request that was generated. In between the request, the server does not keep any data between the two requests. So the Hypertext Transfer Protocol is a very important protocol that is available at the application layer, and it is basically used in context with communication, providing communication between the web browsers and the web servers. The next protocol in the protocol suite is the WebSocket under the application layer category, obviously. WebSockets are basically the protocols that enables two-way communication between a client running an untrusted code in a controlled environment and sending its request to a remote host that has opted into communication from that particular code. So it is basically responsible where the source and the destination, the source is basically an is running an untrusted code. So the WebSocket plays an important role over there. This protocol is commonly used by the web browsers in case of an untrusted code is being run by the application. The next is MQTT. MQTT is basically a machine to machine Internet of Things connectivity protocol. Machine to machine Internet of Things connectivity protocol. It was designed as an extremely lightweight publish subscribe messaging transmode model. It is useful for connection with remote locations where a small piece of code footprint is required over the network bandwidth at a premium rate. For example, it is being used in sensors that are communicating to a broker via satellite link, also over occasional dial-up connections with healthcare providers. It finds applications in a range of home automations and small devices scenarios. So MQTT is also one of the important application layer protocols that provides machine to machine lightweight publish subscribe messaging transmode connectivity interfaces to the IoT devices. Then we have CoAP. CoAP is basically a constrained application protocol. This is a specialized internet application protocol when constrained devices come into picture as defined by RFC 7252 standard. It enables the devices to communicate over the internet. It is defined as the constrained application protocol intended to be used in very simple hardware connectivity scenarios. The protocol is especially targeted for constrained hardware, as I have already mentioned. Example is 8-bit you can say microcontroller or low power sensors that are used in IoT applications. Then we have XMPP. The full form of this is Extensible Messaging and Presence Protocol. This is a communication protocol for message oriented middleware based extensible markup language services. It enables near to real time exchange of structured yet extensible data between any two or more connected network entities, that is the source and the destination nodes. It is basically used in real time scenarios for the exchange of structured data. Then the next in the protocol related to the application layer is DDS. DDS stands for Data Distribution Service. It is a middleware protocol and API standard for data centric connectivity from and is provided by the Object Management Group, OMG. The next is AMQP. AMQP is basically IoT protocol which constitutes of hard and fast component transfers that route and save the messages within a broker carrier with a set of policies for writing the components together. So this all summarizes the protocols that are used at the application layer. Application layer basically acts as an interface between the underlying lower layers and the actual user application. Okay, so it basically hides the implementation details, the complexities of the implementation details from the users of the IoT devices. However, at the same time it basically provides mechanisms to connect to the various underlying layer services by providing a very strong set of protocols that are used in this particular layer. So with this we basically come to an end of the IoT protocol suite. that is used in this physical design of the IoT devices. To summarize, we can say we have the IoT devices or the IoT things, as well as the IoT protocols, which are used to establish the connection or the communication between the things or the devices that are connected over the internet. This was all about the physical design of the IoT system. In the next module, I will be elaborating upon the logical design of the IoT system. So, to conclude, what are the key takeaways from today's lecture? We have studied about IoT, what IoT is. The Internet of Things refer to the things that are connected to the internet or the network. It is basically a network of things. We had also seen the basic building blocks of the IoT system. They are sensors, processors, gateways and applications. Then we have seen the physical design of the IoT system. They constitute of IoT devices called as things and the IoT communication protocols. Then we come up to the logical design of the IoT system, which constitutes of the IoT functional blocks, IoT communication models, IoT communication APIs. These are to be elaborated in the subsequent lectures to be taken on the other days. Then we had discussed the generic block diagram of the IoT devices, constituting of a number of interfaces present for connection with the other IoT devices present on the network. Then we have the interfaces for the sensors, for internet connectivity, for storage, and the audio video interfaces. Last but not the least, we have seen the IoT protocol suite. This constituted of all the communication protocols that are available with IoT. We have seen the 4 layers: the link layer, the network layer, the transport layer and the application layer, and all the respective set of protocols that work in all these layers. These protocol suite is basically used to help the IoT device communicate with the cloud-based server over the internet. With this, we end this lecture. Thank you so much for being a very patient audience. And next, the questions related to the session are invited. Thank you so much.